Chapter 6, Lesson 8, Solve Two-Step Inequalities. You will be able to solve and graph two-step inequalities in one variable. A two-step inequality is an inequality that contains two operations. To solve a two-step inequality, use inverse operations to undo each operation in reverse order of the order of operations. You're basically going to solve them the same way you would solve a two-step equation. But remember, when you multiply or divide by a negative number, you have to flip that inequality symbol. So let's take a look at letter A. The first thing we need to do is undo the addition by subtracting 4 from each side. We get 3x, bring down the greater than or equal to. 16 minus 4 is 12. Divide both sides by 3. We get x is greater than or equal to 4. So 4, 5, and 3. It is a closed circle on 4. Let's plug in a value. Now, you may be able to figure out the value just by looking at it, but let's start with 3. 3 greater than or equal to 4 is false, which means I know it's not 3, so it must go this way. You can go ahead and skip that second step of plugging in the other number. Letter B. We're going to subtract 5 from both sides. And we get 4x is less than 28. Divide both sides by 4. We get x is less than 7. So 6, 7, 8. It is an open circle. 6 plugging in is less than 7 is true. So our arrow goes to the left. Letter C. Subtract 8 from both sides. We get 2x is greater than 16. Divide both sides by 2. We get x is greater than 8. So 7, 8, 9 on our number line. It is an opened circle. And if we plug in 7, 7 is greater than 8 is a false statement. Since 7 is not part of the solution, I know the arrow must go the other way, over 9. So it goes to the right. Letter D. We are going to subtract 7 from both sides. Make sure you bring that negative down. Negative 2x is less than 4. We're going to divide both sides by negative 2. Now remember, we divided by a negative, so we flip the sign. So it's now x is greater than negative 2. So negative 2, negative 1, and negative 3 on our number line. Let's plug in negative 3 for x. Is negative 3 greater than negative 2? It is not. Okay. So we have an open circle on negative 2. 3 is not the solution, which means, negative 3 is not the solution, which means negative 1 is part of the solution. So we shade to the right. Letter E, this time I have minus 5, so I'm going to add 5 to both sides. We get x over 2 is less than negative 3. We're going to multiply both sides by 2. We get x is less than negative 6. So negative 7, negative 6, negative 5, and an open circle on negative 6. So I plug in negative 7. Is negative 7 less than negative 6? It is. So my arrow goes to the left. Letter F. We're going to subtract 9 from both sides. We get x divided by 2 is greater than or equal to negative 4. Again, we're going to multiply by multiply by positive 2. And we get x is greater than or equal to negative 8. So -9, -8, -7 on our number line. It is a closed circle on -8. And let's plug in the first number. Is -9 greater than or equal to -8? It is not. So the arrow goes to the right towards the other side. Letter G, we are going to subtract 8 from both sides. We get -x/3 less than or equal to -1. Now this negative sign can actually go to the 3 or the x. I'm going to put it with the 3 just so I can get rid of it on my next step. And I'm going to get rid of it by multiplying by -3. So then I'm left with x. I multiply by a negative, so I flip the sign, greater than or equal to +3. So 2, 3, 4, close circle on 2, or excuse me, close circle on 3. Plug in a value. 2 greater than or equal to 3 is a false statement. So I shade to the right towards 4, because 2 is not part of the solution, which means it goes the other way. Letter H, I'm going to add 7 to both sides and get 5x is greater than or equal to 50. Divide both sides by 5. X is greater than or equal to 10. So 9, 10, 11 on our number line, and a closed circle on 10. Let's plug in a value. Is 9 greater than or equal to 10? It is not. So I have to shade the other way. So I'm drawing my arrow to the right. Letter I. I'm going to subtract 7 from both sides and get 4 is less than or equal to x divided by 5. So we're going to multiply both sides by 5. And we get 20 is less than or equal to x. 19, 20, and 21. 20 would be a closed circle. And remember, we're going to plug in for the x value, so our 19 that we plug in will go on the right-hand side. Is 20 less than or equal to 19? It is not. So 19 is not the solution, which means 21 is part of the solution. So we shade to the right. Letter J. Subtract 14 from both sides. We get 6x is greater than or equal to 6. Divide both sides by 6. X is greater than or equal to 1. So 0, 1, 2 on the number line. Close circle on 1. Let's plug in a value. Let's do 0. Is 0 greater than or equal to 1? It is not. Since 0 is not part of the solution, 2 must be. So I'm going to shade and draw my arrow to the right. Letter K. Add 13 to both sides. 4x is less than 24. Divide both sides by 4. X is less than 6. 5, 6, 7 on the number line. It's an open circle on 6. Let's plug in 5. Is 5 less than 6? It is. So our solution, 5 is part of our solution. So our arrow and shading is to the left. Letter L. We're going to subtract 4 from each side. We get -24 is greater than -2x. Divide both sides by -2. We get positive 12. We divided by a negative, so we flip the sign to less than. X. 11, 12, 13 on our number line, and an open circle on 12. Plug in your first number for X. Is 12 less than 11? It is not. This is a false statement. Therefore, 13 is part of our solution. So we're going to shade and draw our arrow to the right. Letter M. Halfway through the bowling league season, Stuart has 34 strikes. He averages 2 strikes per game. Write and solve an inequality to find how many more games it will take for Stuart to have at least 61 strikes, the league record. Interpret the solution. So first, let's start off by defining a variable. Let G equal number of games. He already has 34 strikes plus 2 strikes per game, so 2 times G. Now 61 is the record. He wants to have at least 61, so he wants more than or the same as 61. So now let's solve this inequality. We're going to subtract 34 from both sides. We get 2G is greater than or equal to 27. Divide by 2. We get G is greater than or equal to, well, 2 goes into 27. $13.5. Now, we wrote an inequality, we solved an inequality, and we want to know how many more games it will take him to have at least 61 strikes. And it says to interpret our solution. Now, he can't really play half a game and count it as a game. So what we can say is, Stuart would need to play 14 or more games. What we have here is G is greater than or equal to 13.5. You need games greater than or equal to 13.5. Again, you can't play half a game, so we're going to round up to 14. So he would need to play 14 or more games.